Is JD?
JD's not here. Anybody seen JD?
He emailed me yesterday and said that he was aware of everything.
How many emails was that?
What?
How many emails were sent out?
They've received several reminders the past couple of weeks.
Sounds like there's always one.
Yeah, it wouldn't, wouldn't be defensive. So we're just like,
I have to be back at work for the next week. We'll go grab it next week.
Wow.
he does, I guess, technically. Or John, but he's technically on fire. Herbert? I'll see back in January. He and his wife just like,
Oh, wow. Was that a coup?
they didn't do a coup.
I know we're a lot.
It comes from the Norse word rally, which means to rattle, and the rails in Europe have like a rattle-like call. It wasn't actually something I was going to share with you today, but that's what it comes from. There you go. There. Good morning, Robert. Sora, it's a Native American word for spotted. I can't remember what tribe it was.
He's coming home.
Good. It's reassuring.
Yeah, we can move those back.
I'm sure no one wants to sit. My day go a little better. All right.
Okay, today we're here for Auriel Fournier's PhD public defense. She first emailed me back in May of 2011, where she was describing her experience at Black Swamp for working on rails, and that really perked my interest because we had a project on rails that I needed somebody for, and subsequently worked out that she slipped into the position, has been here ever since, and she's been, I was just thinking about it today, she spent so much time on an ATV, which nowadays is equivalent to a horse, that I guess she's qualified as a cowgirl nowadays. But anyway, she came to us from Michigan Technical University. For some reason, I always think Northern Michigan.
That's our rivals.
I know. I did look it up this morning. They're the Huskies. They live over Portage Lake in Northern Michigan, and it was 20 degrees this morning there. So it's probably taking her this long to thaw out after that experience up there. But anyway, she worked on a very large, involved project that she's going to describe here on rails. I'm not going to take any more of her time, so you can read her title and I'll leave it up to Ari.
Awesome. Thank you very much, and thank you all for coming here today. It's great to have such a crowd at 9 o'clock on a Friday morning. So yeah, let's dive right into it. So when I tell people that I work on rails, I often get a lot of real strange looks and questions about why I study trains and the transportation industry. But I actually work on this adorable little bird here and some of its relatives. And rails are members of the family Rallidae. They're usually characterized as being very secretive or difficult to detect. They're very cryptically camouflaged. They have big feet, fairly long legs, at least compared to most birds, and they're wetland obligates, which allows us to answer some really interesting questions about them. And to answer some kind of interesting scientific questions about how birds migrate in general. When we look at rails across the entire globe, they represent a lot of different kinds of life history traits. Some of them are migratory, some of them aren't. Even here in North America, we have one species, the king rail, where some individuals are migratory and some aren't, which allows us to ask some really interesting questions. Rails are also a group of birds that have speciated in a lot of really interesting ways, and a lot of the rails that you can find on small islands in the Pacific have lost the ability to fly, so they allow us to ask some interesting questions with that as well. But one of the things that I find really exciting about rails is the fact that they allow us to really connect a lot of diverse stakeholders. So two of the rails that we're going to talk about today are the Virginia rail and Sora, and those are both game species here in Arkansas and across most of the United States, whereas other rails aren't, but they allow us to connect people who are interested in hunting along with people who are interested in conservation, birding, and just kind of biodiversity in general. Speaking of wetlands, the wetlands we're going to talk about today are just one kind of a very wide variety of wetlands that we can find around the world. But here in North America, and especially here in the central part of the US, we've experienced very wide-scale wetland loss. Many of the states across the Corn Belt have lost between 60 and 90% of their wetlands, which makes the remaining wetlands incredibly important for a wide variety of reasons, especially since a lot of those wetlands are currently in public hands. We have a lot of need to have good information to inform multi-species and multi-use management, so that we can manage cultural needs, so that we can manage recreation, and so that we can also manage wildlife habitat, which is most of what I'm going to talk about today, on these wetlands that, historically would have covered a much larger area and now have a lot more pressure on them as a result. Much of this management is currently being done with a lot of assumptions, and the research that I'm doing and that many other people are doing is trying to assess those assumptions so we have better data to inform that management. The kind of wetlands that we're going to talk about today are impounded wetlands. So they're all palustrine wetlands. They're covered with this very dense annual and sometimes perennial vegetation that has very large seed resources. Because of the way the hydrology has been changed across a lot of this landscape, these wetlands require really intensive management. And in a lot of cases, they become impounded, like these impoundments here at Squaw Creek National Wildlife Refuge. So these are each surrounded by a levee, and that levee allows us to manipulate the water levels in that wetland throughout the year to try and mimic a natural process. All of this kind of management is trying to mimic natural processes that aren't able to happen in these wetlands anymore because of the way that we've levied a lot of our rivers and changed the hydrology, and also the way that we've tiled a lot of our agricultural fields. So through water level manipulation and soil and/or vegetation disturbance, we're trying to create a certain condition for certain animals at a certain time of year. So timing of all of this is incredibly important, and that's a lot of what we're going to focus on today. So when we're talking about rails, when and how we look for these birds is incredibly important. Rails, as I said before, are very cryptic. They're very difficult to detect in a lot of ways, and depending on what species of rail you're interested in, and on what time of year you're interested in finding them, you have to use vastly different methods. So if we want to look at rails during the breeding season, a lot of what we're going to do is go out with a small speaker and use some kind of broadcast survey to try and encourage them to call because they infrequently vocalize. And if we don't do that and we just passively listen for them, we can miss the beginning of migration. We can miss big chunks of their time, which was one of the things that we figured out in my undergrad working with Black-Sword Bird Observatory, who Dr. Kremitz mentioned earlier. We were missing the beginning of migration by about 2 weeks in the spring in Ohio when we weren't using an audio lure. And once we started using an audio lure on traps, we discovered that they were arriving sooner. So it's really important to use the right method. That way we can actually see the full range of what we're interested in. I don't work during the breeding season. I don't work during spring migration. I work during autumn migration, which presents some unique challenges because the call rate of these birds drops off even more during autumn migration, and they don't really respond to that playback anymore. So we had to figure out a different method. Luckily for me, ATVs are a lot of fun, and we figured out one that involved that. So Perkins et al. Several years ago, with Sammy King and others down at LSU, figured out that you can go out at night and catch rails on ATVs. And you do this, you drive through the wetland, flush the birds, they fly a short distance, you can drive over next to them, hop off, throw down a dip net, catch the rails. It works really well. And kind of based on that framework, we're like, okay, well, if the birds flush a short distance and you can identify them, maybe we can develop some kind of survey method around this flushing behavior. So instead of having a survey method like you do for most birds, which is very audio-based, where you're going around and you're listening for them, this one is entirely visual, which presents some unique challenges. such as there is a rail in this picture. So what we do is we drive along at night with a spotlight and we're looking for rails in the vegetation. About half of them that we see actually flush, but about half of them that we see are just sitting in the vegetation like this little guy right here. So a lot of the training that goes into doing the survey method requires developing a pretty specific search image for birds like this little sora here that's hiding in the vegetation. So there's going to be a little animation here on the left that's going to show you guys kind of how this works. So we're doing all of this under a generalized hierarchical distance sampling protocol. If that doesn't mean anything to you, that's fine. Basically what happens is the ATV is driving along in a serpentine pattern, and all of these black dots are birds. And every time a bird is detected, it turns red as the ATV drives along. And at the end of the survey, every time we detect a bird, we measure the distance from the bird to the transect line, and then we can look at how the counts drop off as we get farther away from the line, and this is how detection probability is dropping off. And then we can use hierarchical models to get density estimates by accounting for that drop off in detection. I'm not going to get any more into the stats than that right now. If you have more questions later, I'm happy to answer them. But this is the kind of general framework I'm using to get the density estimates and ask some of the experimental questions. Okay. Anyway, you all know where Missouri is. This is Missouri. I work on 11 different state and federal properties. The state properties are managed by the Missouri Department of Conservation, and the federal properties are managed by the U.S. Fish and Wildlife Service. So starting in 2012 and going through the fall of 2016, every year the second week in August, we started up here in northwestern Missouri. We were there for a couple nights, then we moved to north central, northeast, southeast. We do 4 big loops of the state every year. This allows us to look at how density changes across time at a single site, but also how it changes across the state, across the entire season, and across the 5 years of the study. So over that time, we've seen just over 8,000 rails. About 95% of them are sora, so that's most of what we're going to talk about today. But we've also seen Virginia rails, yellow rails, and a couple of blue rails. So kind of the first question that we had when we kind of came into this project was trying to understand when these birds are migrating. We had a few ideas, especially for sora from the literature, but we wanted to see when they were migrating and how that was varying among years. And so this is median sora per hectare, which is coming out of those models that I just talked about. And we're looking at how density changes across the year, and this is averaged across all 5 years. And so something that became apparent within the first couple of years was that the birds are always showing up in the second week of August. Occasionally they're showing up slightly earlier, but they're always there in the second week of August. And that kind of regular arrival suggests that the migration of these birds is triggered by something like photoperiod or day length, something that isn't variable from year to year. But when we looked among years at the peak of migration, we started to see some slight differences, which suggests that something like weather is also playing a role in how their migratory timing is working. But sora are migrating through the state from around the second week of August well into the end of October, and the peak of migration is usually in the second 2 weeks of September. The last 2 weeks of September. For yellow rail and Virginia rail, we're dealing with a much, much smaller sample size. So this graph represents about 7,900 detections. There are less than 100 detections in each of these graphs. So we're dealing with a very different sample size. And so we're going to look at this data in a very different way. So there's a couple important things. For the moment, ignore this, I'll explain it in a second. Look at these top two. So the data from my project is represented in these filled-in distributions. So we have time on the x-axis, and this is a relative density. These open distributions represent opportunistic data. This opportunistic data is things from building strike records, eBird, and the Missouri Audubon Society. When I figured out that we were going to have a much smaller sample size for these species, I wanted to find some other data sets to compare my data to see how the patterns match. So we sought out these other kind of opportunistic data sets. And then these bars here at the bottom represent kind of the best guess for migration from the Birds of North America accounts. So each species of bird in North America, there's several experts that every couple of years write up an account of basically everything that's known about that species. And for autumn migration, this is when those two accounts estimated that they were migrating. And so this allows us to compare the stuff that comes out of my project with what's going on in the opportunistic data and kind of what the experts were estimating. So for yellow rail, we can see that the distribution of this, this study being my work, and the opportunistic data are pretty similar. These two peaks are statistically significantly different, but we're dealing with pretty small sample sizes, so I'm hesitant to make any more conclusions other than that. But they do pretty well overlap with this, so the migration is starting slightly earlier and going slightly later. But with yellow rails, it seems like my data is fairly consistent with other data sources with a little bit of variation. But again, very small sample sizes. For Virginia rails, you see something really different. I really have no explanation for this double hump in the opportunistic data. It's certainly not what I was expecting, but you'll see a theme throughout all this. When you study rails, things don't go as you expect them to. But my data kind of shows, some interesting little peaks, and it really doesn't match up with what's coming from the birds of North America account. These birds are starting right away in early August and continuing through the end of November in both my data and the opportunistic data. So something is different between kind of what the experts were guessing, since autumn migration for these birds isn't really studied in my data. But again, small sample sizes. This stuff is more descriptive and hopefully informative for future research. Okay, so once you kind of figure out when the birds are migrating, the next basic question is what kind of habitats are they using? So I looked at habitat use for all 3 species, but today we're just going to talk about soras for the purposes of time. So to do habitat selection, the way that this worked is we have a 5-to-1 ratio of available to used habitat. And so what that means is every time we see a bird during our surveys, we take a GPS point. And then the next morning we come back and we do vegetation data collection at those points, and also at 5 random points for every 1 point where we see a bird. And what that lets us do is compare the site that the bird has selected within that wetland versus what's actually available in the whole wetland. And we did that using binomial mixed models with area within year as a random effect. Okay, so these are the 6 variables that we looked at for our for SORA. And so what we see, so each of these lines represents a different year. So we have a little bit different relationships among years, but we'll start over here. So annual vegetation is annual moist soil vegetation. This is smartweeds and millets, very dense vegetation with very abundant seed resources. And we have positive selection by SORA in all years for annual moist soil vegetation. In all years, we have negative selection for open. So this is areas with no vegetation. This is either bare ground or open water. Remember, these birds are very secretive. They don't like to be seen, so this isn't too surprising. They don't want to be out in the open. Perennial is our perennial moist soil vegetation. This is things like cattail and bulrush, very robust wetland vegetation. And we're seeing very weak positive to no selection depending on the year. Excuse me. And this is kind of surprising since especially Virginia rails are very associated with this habitat type during the breeding season, but it may suggest that during autumn migration, these birds are selecting for something different, probably for those very heavy seed resources in the annual vegetation. For vegetation, we have a negative relationship for SORA in all years, and again, that's not super surprising. These birds are wetland species, they're keying in on that wetland veg. Most of the upland vegetation we see is right along the edges of the wetlands, and that's not usually where we find the SORA. In all years for woody vegetation, the general rule of thumb with rails that they don't like trees. These are, for the most part, smaller trees, but we're seeing the same relationship. For average water depth, we allowed it to have a polynomial, so we have a second order relationship. And despite the fact that the height of these curves is different among years, we're seeing a positive selection up to about 20 to 30 centimeters, and then it starts to be negatively selected as we get deeper. So they like water. They like wetlands that have water. That's surprisingly hard to say, but only so much water, which again, not super surprising. While these birds can swim and dive, they're selecting kind of in this middle range. Okay, so all right, one thing, remember this whole 20 to 30 centimeter thing. So if you recall from earlier, I said that we visit each site 4 times a year. And each time we're there, we're collecting data about the vegetation and how the water depth is changing. So we can look at how water depth changes over time relative to how things are being selected by the birds. So if the birds will select between 20 and 30 centimeters when it's available, how much is it available? Not much. So this is the first visit, second visit, etc. of the year. So in the first 2 visits, we have basically no water. I mean, there are obviously some points where there is water, but on average, we have very dry wetlands. And then as we get into the later part of September and October, the wetlands start to flood up, but at no point during autumn migration is the median water depth within that range that they will select given it's available. So they're selecting things that are fairly uncommon on the landscape, which could have impacts on their survival, how they're using the habitat, how long they stay in the site, a lot of different things. And kind of because of this mismatch, we worked really closely with Missouri Department of Conservation and the U.S. Fish and Wildlife Service, and we sat down with all the managers and a bunch of different scientists from both agencies back in 2014, and we were like, okay, here are some patterns that we're seeing in the data. Here are some ideas we have about why those patterns may be. How can we answer, get a better handle on this through some kind of an experiment? And we wanted that answer to be something that would be very informative to those agencies and to those managers. And kind of one of the concerns that came out of that meeting was that, if we flood wetlands earlier in the year for rails, which is kind of what our data suggested we should be doing, what is going to be kind of the downstream effects? How are waterfowl going to be impacted? Waterfowl are a really big management concern on a lot of these areas. For a lot of these properties, waterfowl habitat was the reason that they were originally protected as public land. So we wanted to try and figure out if there were any trade-offs between flooding these wetlands earlier in the year for rails and then what would happen later for waterfowl. So we designed an experiment. Originally, it was supposed to be a 2-year experiment with a kind of a crossover design where a wetland that was early flooded in one year would be late flooded in the next and vice versa. But if you've ever done field work, nothing goes as planned. We had a lot of flooding issues the first year. So we expanded it into a 3-year project, which allowed us to kind of keep our sample size at a more respectable level. And this is kind of how the treatments work out. There's a little bit of variation here, but basically the early treatment starts flooding in the early part of August. And as long as it's above 7 centimeters, which is this horizontal line, by the middle of August and stays at that level, until the end of the season, it's an early treatment. Our late treatment wetlands begin flooding in the middle part of September and reach above 7 centimeters at the end of September and then stay that way through the waterfowl season. If a wetland at any time was over 40 centimeters average water depth, we considered that a major flood event and we excluded it from the data set, since those flood events often had a really negative impact on the vegetation communities, and we didn't feel that they were representative of things that waterfowl or whales would use. So we ran this experiment for 3 years. The waterfowl data I'm going to show you was just got done being collected like 3 weeks ago. So this is all very fresh and pretty exciting. So this is looking at our SOAR response for each visit. So you remember we did 4 visits every year. So we have maximum count of SOAR as our response. And that maximum count comes during every visit. Each wetland is surveyed 2 times by 2 different people. And so we take whichever count is higher for that wetland in that visit, and that's our response. So early in the season, we're not seeing a significant difference between the 2 treatments. And my hypothesis is that this is because there are very few rails using these wetlands very early in the season. Our median counts are 1 or 2 birds a night, so it's very difficult to tell a difference between the treatments. But by the time we get to the 3rd week of August, we're starting to see much larger movement of SORA through the state, and so we start to see positive selection for the early treatment, and that selection continues into our 3rd and 4th round. One thing that I think is really interesting here, so in our first 2 visits, the early treatment has water in it, the late treatment is dry. That's not true over here. In the 3rd and 4th visits, the early treatment has water, but now the late treatment also has water, but we're still seeing higher use by the rails in the early treatment. And I have a couple ideas about why that might be, but I haven't really been able to test them yet. It could be that maybe SORA are selecting for wetlands where other SORA are. Hearing SORA calling or something may be part of their habitat selection process during migration. It may also have something to do with availability of food resources, or it might have to do with how long these birds are staying at the site. But I don't really have any data to kind of rank one of those over the other at this point. But kind of the take-home message is that when you flood rails earlier in the season, you see higher use by rail. Or flood wetlands early in the season, you see higher use by SORA. Waterfowl. So the waterfowl data was collected for me by all of the managers. So they very graciously volunteered to go out once a week from October through January and count waterfowl in my experimental comments. And so they did weekly counts, and then we broke the data up into 2-week blocks. And so what we did was we took the maximum count for each of those 2-week blocks and used that as our response. And we had a treatment by year interaction, so I'm showing you across the 3 years But basically, we have no significant difference between treatments. So even though these wetlands have had water in them for like an additional 5 to 6 weeks, the waterfowl are using them essentially at the same amount. In some years, we have just kind of variation in how many waterfowl there are. Like in 2014, 2015, a little over 10,000 was our highest count. In 2016, 2017, almost 20,000, which is I think why we have that year by treatment interaction. But in all cases, we still do not have a significant difference between the treatments, which means that if we want to manage some wetlands, a lot of these properties comprise a few to dozens of wetland impoundments. So you can take a couple of those impoundments, flood them earlier in the season, rails, our data suggests, will respond to it, and there won't be a negative impact on waterfowl, which is really exciting. Okay, so the last part of my dissertation we're going to talk about today is talking about this concept of migratory connectivity. So migratory connectivity is this idea that, we have a bunch of birds in the breeding range. This isn't a map of rails, it's just anonymous bird species. So the idea is that birds that breed here in the Midwest are more likely to winter together than birds that breed over here on the East Coast. That there's some kind of connectivity between different parts of the annual cycle. And there are a lot of different ways to study migratory connectivity. This is something that ornithologists and ecologists in general have been interested in for a really long time. And a lot of times we think about doing it through something called bird banding, where you put a little band on the bird's leg and catch it later. But that only works when you get a lot of recaptures, which if you're working with something like waterfowl, where they're widely banded across the continent, and you have a lot of people out looking for them and hunting them, and you get recaptures, works really well. This is every rail that's been recaptured in the United States in the past 100 years. I am not kidding. So bird banding wasn't really going to be an option. This is about 45 individuals across 6 species. So bird banding wasn't going to be a way for us to look at migratory connectivity. There are some other ways. We could have put satellite backpacks on the birds or done geolocators. For satellite backpacks, a couple years ago when I was designing this, they weren't small enough yet. They were too heavy. This year they're coming out with ones, and maybe in the next couple of years we'll be putting out backpacks. But the point that I started this study wasn't feasible. Geolocators, you have to be able to recapture the bird, and rails have incredibly low sight fidelity, so you're basically just strapping money to a bird and never seeing it again, which is also very inefficient. So what we decided to do was to use a method that allows us to estimate the breeding range that a migratory bird came from, and that's using stable isotopes. And the way that this works is hydrogen isotope ratios vary roughly with latitude across North America. And so when a bird molts its feathers on the breeding grounds, for rails, that's somewhere up in here, the ratio of heavy to light isotopes of the precipitation at that location is captured in their feathers. So bird breeds, bird molts, that feather is an inert material, so it's not changing over time. It migrates down to Missouri, I catch it, pull the feather, and that feather holds that signature, and so I can estimate and backtrack to where that bird came from on the breeding grounds. The big advantage to this is we only have to catch the bird one time, because I can pull the feather and have the information. So it's really helpful that way. One of kind of the weaknesses of stable isotopes is we get really, really broad estimates of where the bird came from. So you guys see like these big bands of color. And that can be really helpful if you're concerned, is my bird coming from up here, up in the territories of Canada, or is it coming from the Great Lakes? You can tell that difference. But it's actually possible to assign a bird the same value in Seattle and in Maine, which is maybe not as informative as we'd like it to be. Luckily, there are ways of incorporating additional information into these assignments, and people have done this in a lot of different ways. People have included genetic information. If you know how a species varies genetically over space, you can use that information. Folks have also used population estimates. So if you know how a population varies across time and space, you can use that. We don't have either of those for rails. It's probably the theme you're picking up on. So one thing that we did do was we developed species distribution models, which allows us to look at relative differences in population by using monitoring data. So all of these points are points where the Marshbird Monitoring Program has been run sometime in the past 10 years, either by Bird Studies Canada or by U.S. Fish and Wildlife. And so we were able to take the points there that either run during the breeding season and use that to create a species distribution model for all 3 species. And then in a Bayesian framework, we were able to incorporate that with our assignments, and it helps us to get more specific assignments for our stable isotopes. These different states are colored in different colors because these are the different places that we got feathers from. So we have all 3 species were collected by me in Missouri, and then we had hunters and other researchers from all these other states collect different combinations of whatever rails it was that they came across. So we could kind of look at what was going on at a larger scale. And I'm not going to go into all the fine details of the species distribution models. If you're curious about that, I'm happy to talk about it later. But what this represents is, so after we do the assignment for each individual bird, we get a surface. And this is the summation of all those surfaces. So we have a spatially explicit estimate of where that bird came from on the breeding ground. And then for soras here on the left, we have 91 of them, and then we basically just add them all together. So this allows us to look at where the average, basically, of all those birds are coming from. So first thing to point out, we're dealing with very different sample sizes again. We have 91 sora, 5 Virginia, 11 yellow rails. So again, especially take these 2 with a grain of salt. But one thing that probably initially jumps out at you is that these 3 maps look pretty different. So sora, most of our sora came from Missouri and Louisiana. So these birds are coming more than likely from kind of the upper Great Plains area. For Virginia rails, we'll talk about that in a second. Let's talk over to yellow rails. Yellow rails are coming from a very different area than sora, even though these yellow rails were caught on the same sites in Missouri and Louisiana and then also in Mississippi. These birds are coming from up here in Ontario and Manitoba and the upper Great Lakes. So even though these birds are using the same wetlands, our assignment suggests that they're coming from different areas, which is pretty interesting. This Virginia rail map, which is a very small sample size, but it's picking up on kind of a strange pattern. So we have 2 birds that were assigned up here in the prairie potholes in central Canada, and then we also have birds that were assigned here to eastern Colorado and western Kansas, which suggests that they're migrating east-west, which, I mean, rails do funny things. This is just an estimate, and this kind of stabilized tope work is very kind of first step informative. But what I will say is I worked on a project in my undergrad for my undergrad thesis on Virginia rails using stable isotopes, and we saw this same pattern, which to me suggests that Virginia rails are migrating in a different way. I'm not saying that they're migrating east-west, but something about their migration or about their molt pattern is different, or it's possible that the food resources that they're using when they're molting is somehow affecting the fractionation of that hydrogen in their feathers. And that's a question I can't really answer until we strap backpacks on these birds and actually track them the whole year round. But this is the second time I've seen this real funny pattern where it looks like rails are migrating east-west or maybe even over the Rocky Mountains, which super makes no sense, but rails do strange things. And until we get more data, this is what we've got for Virginia rails. But regardless, these 3 birds' maps show different patterns. So these birds are migrating in different ways, which is interesting because a lot of times we talk about rails as if they're kind of one homogeneous group. But they're doing different things, which is pretty cool. Okay, so let's pull this all together. We've talked about a lot of different things today. I've kind of whisked you through 5 of my 6 chapters. I didn't want to push you guys through like 3 hours of very detailed stuff, but we can talk about the details later. So to pull this together, rails are often discussed as a group. You know, we talk about rail management, we talk about rail migration, but this group of birds, you know, they're occupying slightly different niches. If I had had time, I would have shown you the habitat data for Virginia rails and yellow rails, and you'd see that they're occupying slightly different niches as well in habitat use. So hopefully kind of one of the things my dissertation has been able to do is kind of set the base work for more study of these 3 birds, but also understanding kind of the nuance between the 3 of them. Because I think that's going to be really important for managing these species in the future. You know, and the other big thing that comes out of this is we can manage wetlands for sora without having a negative impact on waterfowl, which is really a win-win. If we want to have multi-species, multi-use management, we need to understand these trade-offs, and we need to try and find these situations where we can do good things for multiple species. So kind of what is next for rails? You know, any good dissertation creates more questions than it answers. So, you know, we need to continue to ask experimental questions about habitat. You know, we've looked at trade-offs between rails and waterfowl during one time of year. But there's also big questions. How is this impacting reptiles and amphibians in these wetlands? How is it impacting the invertebrate community? How is it impacting water quality? You know, how is climate change going to factor into this? There's a lot of other questions that need to be answered. This is just one drop into a very large bucket that needs to be filled to understand how wetland management can be more robust. We also don't know how long rails stay at a stopover site. We have some idea that they might actually be staying for quite a long time, but we don't have solid data on that. And that would be really informative, because if you remember the graph of the Sora migration, they're in Missouri for almost 3 months. And if they're there for several weeks, that means that we're dealing with a smaller number of birds, because if you have very quick turnover, you're talking about a lot of birds moving through. But if we have longer stopover, we're talking about fewer birds. But right now, we don't really know the difference, which really kind of limits how we think about how Missouri fits into kind of a population of soras in general. We also need population monitoring. So I see 60 sora for every 1 Virginia rail that I see. But I don't know if that represents their true numbers on the landscape scale or their populations. We kind of expected to see more like a 1-to-1 ratio for soras to Virginias, but because we don't have population estimates for any of these species, it's really difficult to kind of infer much more than something's going on. It could be the method, it could be the wetlands, it could be the actual representation on the ground. So we need good population estimates. We also need to kind of get more at this question of what time of year has the biggest impact on survival. So my work kind of looked at habitat selection, kind of looking towards questions about survival, but we didn't explicitly look at survival. And that's really important. We also need more method development. So ATVs in moist soil wetlands in Missouri work really well. But if you put an ATV into a coastal wetland, the ATV will not come out again and you will not get any data. But we need to study birds in the fall and in the winter in coastal systems. We need to study them in systems that have really delicate vegetation that can't support ATVs. So we need to kind of keep thinking outside of the box to develop more methods for rails as well. And we also need to answer more questions about migratory connectivity. Stable isotopes are by no means closing the book on migratory connectivity for rails. This is a first look. It gives us some kind of crazy hypotheses that we can work with in the future, but we need to keep answering those questions as well. Okay, so one thing that I want to share with you guys that I think is really cool and something that I learned during my dissertation is that sora can swim and dive. And so this is a video that I took, and this is at Nottoway Valley Conservation Area in Missouri. And this little bird is going to swim along. In just a second here, it's going to dive into the water, which is kind of a behavior that we didn't really, it's sort of talked about in the literature, but nobody really knew about it. And it really kind of changes how we think about how these birds kind of access habitat. Because if they can, I mean, I've seen them, I don't have a video of it, but I've seen them swimming under the water. You know, they can access resources that we didn't think they could access before, which I think is really cool. Not super relevant necessarily to the results of my dissertation, but pretty cool nonetheless. They're really fascinating little birds. Okay, so some thank yous quickly to our many different funding sources. U.S. Fish and Wildlife and Missouri Department of Conservation have been huge, vital parts of this dissertation. In addition to the co-op unit, Garden Club of America, Arkansas Audubon Society Trust, and Bird Studies Canada. I've had many, many amazing technicians work on my project the past 5 years, and none of this data would be here today, and I probably wouldn't be either if it wasn't for them bailing me out on many occasions. So I'm incredibly grateful to have had them work for me. And it takes a lot of people to get through a PhD. I really appreciate all of you being here today, and my many thanks to many other people who have helped in a variety of ways over the years. And with that, I'm happy to take any questions you guys have. Yeah, wait.
Auriel, great talk. That was awesome.
Thank you.
So you suggested that earlier the flood up would be better for these trails in the fall anyways.
Yeah.
So working in the same wetland almost that you have
Yeah.
has I ran into issues with managers not being willing to flood up early because they also drop these wetlands.
Yeah.
You see that being an issue.
Yeah, so that was one of the things that we ran into when we were kind of designing this experiment. So if you're not familiar with kind of how moist soil management works on a lot of public land, they actually let farmers come in and plant crops in some of these wetlands, and then some of that is harvested and the farmer takes it, and then some of it is left for wildlife food. And so in this experiment, we explicitly left out wetlands that were majority cropped. So which left us, with ones that were largely dominated by smart weeds and millets. So it's certainly something that could only be used under certain conditions, and I think the managers were very aware of that. But the really big wetlands tend to be the ones that get a lot of cropping anyway, and I don't think they'd want to do this kind of early flooding in the really big ones. So I think it kind of balances out. But yeah, that's definitely a concern. Yeah. Yeah, Tom.
Was really interesting.
Thank you.
So one question I had on one of the slides where you're sort of bringing together some of the isotopia and some of the detections in Canada.
So this one?
This one going into the next one.
Yeah. What about it?
Were there provinces that you didn't have data from?
Yeah, so for the species distribution model, like our points don't represent the entirety of the breeding range. But because, so we fed in a bunch of environmental covariates that cover the entirety of the area. And so we were able to extrapolate onto those areas with the assumption that the relationships stay the same, which is definitely an assumption. But yeah, I mean, like there are tons and tons of marsh birds that are breeding here in the northeastern US, and I just didn't have that data. And there are definitely them breeding up farther north in Canada. But you know, we work with what we've got. But yeah, that's a very good question. Yeah. Yeah.
So Auriel, besides knowing that the waterfowl that have the earlier lake flood come through Missouri earlier than some of the more southern states, I guess how far down do you think you would hit an effect of it? Like let's say you're managing in southwest Mississippi. If you did an early flood up, would that have more of an effect down there than if you started that in the middle of Missouri? You understand, I guess what I'm asking.
Yeah, well, I mean, Missouri is still a wintering habitat for a lot of these ducks. I mean, there were lots and lots of ducks still in Missouri at the end of January. So, I mean, if you were going to try and implement earlier flooding for rails, like on the coast, you'd need to adjust the timing for when the rails are arriving. But a lot of those wetlands are like a very different vegetation community, and they're being managed in a different way. So I would be really hesitant to like just pick up these results and throw them into those wetlands, just because there's a lot of different things going on in that system. And since I haven't worked a lot in the coastal system, I'm not really sure what would happen. But I mean, we are definitely still dealing with wintering habitat. I mean, if it's a very severe winter, all the ducks will move farther south. But the past 3 years, there's definitely been waterfowl in Missouri the entire winter, or at least through the end of January. So, does that kind of answer your question?
Yeah, because I would imagine this would be, it would cover like a 600-mile radius from your study sites of being pretty true.
Right. I mean, if we're talking about, like eastern Kansas, Illinois, kind of this whole area, I think you can kind of extrapolate to that point. Because those wetlands, a lot of them are managed under moist soil. They're dealing with similar conditions. But, I mean, once you start moving down into coastal areas, I would be hesitant to start making any kind of recommendation.
But like you mentioned before, the thing with managers is incorporating them, you have all these wetland units on your area, you can just set aside 2 or a couple of these.
Right. We're definitely not saying manage all of your wetlands and start flooding them in August. We're saying if you want to manage for rails, take a couple of your wetlands, you can flood them up in August and it won't negatively impact us. Yeah. Yes.
So you said that birds for less than 30 centimeters, they're approximately no more.
Yeah.
And I was wondering, is their diet rather broad or rather kind of narrow? Could they be selecting just based on, if it's flooded too much, they're not going to
Right. So there hasn't been a ton of dietary work that's been done on rails, but what has been done suggests that they've switched almost an entirely seed-based diet in the fall. Though the composition of those seeds, I don't think has been super well understood. From my understanding, it's mostly like millets and smartweeds, which are what dominate most of these wetlands anyway. But the height of the water could definitely impact because most of those seeds are like at the top of the plant. So if the water is higher, it would make those seeds more available. But if they're able to dive, they could also access resources there. That would be something really interesting to look into more in the future. It's not something I can speak super specifically about today. Yeah, did you?
Any comment on in terms of what you can conclude about migratory connectivity and rails, how they compare to other birds, the waterfowl or things like that? Are they different? Or are they...
So I mean, when we kind of think about waterfowl management, we talk about how there's like a Mississippi flyway, kind of a central flyway, Pacific, and then there's one over here on the East Coast. It looks like yellow rails. So like Missouri is on like the western part of the Mississippi flyway. And the idea is that waterfowl are moving north and south through these corridors, so there's definitely some movement in between. And it looks like yellow rails based on 11 birds are staying within that flyway, but there's probably some crossover among sorrel. I mean, in Virginia rails, there's still such a mystery in my mind. I'm not really sure. But like my undergrad work on Virginia rails was with birds from Louisiana, and I mean they were showing this similar pattern too, which suggests that they're crossing as well. So while the game species especially are being managed by the flyway, which is both kind of like an ecological thing and an administrative boundary, there is some crossover, but that's also true of waterfowl.
So a future selection or a major project, what do you think?
I think the thing, from like talking with other people who work with rails and kind of talking with other people, kind of the patterns they see, one of the big things is that a lot of these questions are being limited by the fact that we don't have population estimates. To me, that's kind of a big missing piece. Because there are other people that are seeing kind of strange patterns in some places with Virginia rails, and it kind of suggests, at least to me, that Virginia rail populations might be much higher in the east and they drop off as you move west. Because people working in the Great Lakes are seeing different ratios than people on the East Coast, but we really don't know that until we have good population estimates and we know how that varies over states. So to me, that's kind of the next like immediate need for a lot of people. But for my stuff, it would be kind of asking kind of some more experimental questions and also like strapping transmitters on birds and trying to get a better idea of what's actually going on with connectivity so we can like track an individual bird the whole year rather than estimating backwards. Because I mean, these are estimates. I mean, and stable isotopes have a lot of assumptions with them that I didn't get into today that you take into account when you look at this map. So it would be really a lot better to be able to say this bird was here within 500 meters on this day. And hopefully sometime soon we'll be able to do that.
I guess building on the population estimate question, your density estimate for rail, for sort of, migration was pretty high. 60 per hectare was a lot of birds. Is that surprising to you, or did it surprise managers when you told them that there's millions of rails out there? That
it doesn't seem to, for soars, it doesn't seem to surprise anyone. I mean, if you talk to the hunters that I run into, like the teal hunters and the managers, they know that at the end of September, when you're out hunting, you pick up rails all the time. And like I've talked, so the stable isotope work is with some collaborators with Bird Studies Canada, and they've been doing the marsh bird monitoring program across most of Canada for many years now. And they've done some like back of the envelope calculations, and I mean the soar population is huge. So these densities don't seem to surprise anybody. It's the lack of density in Virginia rails that's more surprising. Was there another hand? Or no?
No, mine was the same.
There we go. To the point. All right.
All right, thank you very much.
Yeah, thank you.